But hello everyone, thanks for coming along tonight. And for those online, thanks for tuning in. Tonight I am talking about Inertia JS. I'll cover what Inertia JS is and how it works, but I'd first like to start with a little backstory for how we came to be using Inertia JS and a little bit about what that journey looked like for us. Obviously there is time for questions at the end, but for those online, just post them whenever and Ben will read them out on your behalf at the end. So let's start with who I am. My name is James. I'm a team lead and I'm a full stack developer here at iSeek Plant. Sometimes I write about ideas or solutions I've had to problems on my website, and I'm also on Twitter if that's your thing. So whether you're building similar applications or not, I think giving an overview of the types of things that we've had to consider when deciding to adopt Inertia may help you decide whether it's something for you, but it may also highlight things that we haven't had to consider when deciding it as a technology that we want to use. So we build a handful of customer-facing applications. We have a portal for our searchers, our suppliers, and our partners. And we have a lot of internal applications that support our platform. And these are usually some form of administration tool. Each of these applications is what we call a macro service. I spoke about this in more detail at our last meetup, but this basically just means that they are a focused monolith, and they may expose an API, a front end, or both. And all of these applications are built by a relatively small team of full stack developers. And I mention that because the UI is built and managed by us as experienced, but we're by no means expert front-end developers. And lastly, all of the applications that we've got bar our searcher application will require authentication to be used. So we're a Laravel shop. All of our applications, big or small, are built using Laravel. And historically, we were building our front ends with a mixture of Blade, jQuery, and Bootstrap. And as time went on, we did make some efforts to try and modernize our front-end tooling. We shifted to using JavaScript classes for our jQuery, and we rolled our own version of code splitting to try and make this work better with our JavaScript classes. But it was around mid-2019 we began moving towards Tailwind, and we stopped using Bootstrap. And by late 2019, we were beginning to use React. Now, it didn't take long for us to fully adopt React, and very soon we were quickly building all of our new work using React. At this point, we were really enjoying React. It was vastly better than jQuery. I mean, jQuery has its place, but I mean, React is great too. Pretty much. Every time we have to go back and look at the legacy stuff, it's a little bit painful. But we were using server-side routing to load our views, and those were in turn booting our React components. We wanted to push more towards an SPA experience. You see, we were already building 99% of our front end in React, and this would help us tip that scale a little more and remove this unnecessary duplication where we have to string up these views, which are just simply there to boot our React components. It also meant that all of the existing APIs that we'd already built to interact with these React components could still be used. SPAs can come with some additional bonus features. You get the option of things like PWAs, offline support, you get the opportunity to statically host the front end, amongst other things. But to get all of this, we would have to move the routing for the front end to the client side. Data fetching would almost exclusively have to happen via APIs. We would no longer be able to route via a controller and just pass props in like you can with Vue, with the Blade views. And we would need to consider how we have to manage any persistent state as we move around our SPA. And finally, we need to consider if we need to recreate any browser behavior, like our backwards or forwards navigation, and how that might interact with our components, so we make sure that the state of those is restored correctly. So what was it about SPAs, or what was it that we actually wanted? Well, we want the front end to be entirely in React, and we don't want to be managing routing in two places. It would be nice if we can continue to pass data into our components like we do with Blade. So inside your controller, fetching any data that you need and then passing it down. This would reduce our need for a route that would then be rendering a view or a component that would then need to use APIs to go away and fetch more data. And we'd like to get that single page experience where we aren't rebooting React on every page change. And this would also help us keep things a little snappier on the client side. So enter Inertia JS. This is a library that allows you to quickly build modern single-page apps using classic server-side routing and controllers. Let me just pause for a minute and ask a couple of questions. How many of you have heard of Inertia JS? Yeah, about half of you. And how many of you have used Inertia JS? Far fewer. Okay, cool. So you know a little bit about what it is, maybe. Some of you obviously never heard about it before. So that's kind of cool. Okay. So before I talk about how it works, why don't I just show you what it looks like in action. So here I have an application that is loaded. I'm browsing around on it at the moment. It may be a little bit hard to see, but as I navigate between each page, the application is not performing any full page reloads. There's no white flash as React boots up again on each page change. And as an added bonus, we were getting a nice kind of progress indicator that runs across the top that I'm sure you're familiar with. So what's actually going on with Inertia? Well, on our first request, it's something that is akin to your traditional server-rendered page. We're loading HTML, we're loading all of the assets that we need, and anything else that is required to load and boot that page. On any subsequent request, though, we are simply returning JSON with the information that Inertia needs. Taking a practical look at what that means, here's a look at the network tab for the first page that we load. On the right, we've got the HTML response, and then on the left, we can see all the assets that are getting loaded in when we first boot this up. Ooh, that jumped too fast. When we navigate to another page, though, you'll notice that we just get JSON back. This tells Inertia which component we want to move on to, and any props that should be passed into it. So how do we get started with Inertia? Well, first, we need a base view. And this is what your typical base view would look like. We are loading our CSS and our JavaScript, and then we use the add Inertia blade directive, which will allow Inertia to render their root div and work all the magic that they need to. Next, we need to tell Inertia where to find our components. If we remember back to the network tab, we saw that the Inertia response tells us which React component to load, but we have to tell the Inertia library where to go and find that component. In this example, we are importing the app component from Inertia, and we pass two props to it. The first one is the initial page. So when we first boot our application or a user first loads it up, they need to know which component to load in. And this is handled for you by Inertia. They take care of all of that data set that goes on their root div. You don't have to worry about that. The second one, though, resolve component. When it comes to loading or resolving the page component that we've asked it to, we need to tell Inertia where to go and find that component. Now, an example like this would typically live in like your app.js file or something similar. And in this case, we are telling Inertia that our page components can be found in our pages directory. If you want to enable code splitting for your components, then this is quite easy. We just have to update how we resolve the components. We start to use dynamic imports rather than the require syntax. Now, this does require a Babel plugin, but you get the gist of it. And finally, we need to pass the components and the props for each page to use. If we take this fairly typical blade example, we are loading a machine's index view, and we're passing down the machines that we want to show on that page. Now for us, prior to Inertia, this would have just loaded a machine's index, the view would have just booted a machine's index component and then passed the machines in as a prop. To swap this over with Inertia, we just need to use the Inertia render method and pass in the name of the component that we want to use and any props that we want to have passed into it. As you can see, the syntax is very natural and familiar to that of a traditional blade view. So with installation complete, how do we go about using Inertia? First, you'll need a way to move between your pages. This Inertia link is effectively just a wrapper around Axios. It sends some special headers with each request that tell the server-side library to give us back a JSON response. Now the API for using it is exactly the same as if you were using an anchor tag. And as long as the page that you're navigating to also returns an Inertia component, then this is just a straight swap for any of the existing anchor tags that you've got. That said, it's not just for GET requests. Perhaps you need to send a POST request to log out. You can even go so far as to send data along too if you want. Now, I've not personally used the link for sending data like this, but I can certainly see a use case for it when you're doing something simple like toggling a state of something. Maybe you're enabling or you're disabling something. And perhaps then a nice follow-on from that point is how do we handle form submissions or sending data if we're not using the Inertia link? As I mentioned, you could use the Inertia link, although it's not typically what we do. And perhaps more commonly, you would use the Inertia client instead to make your requests. I hope you guys can all see that. But here we have what I would view as a more typical way to work with forms. You have the form itself, which contains all of our inputs, and a submit button for when you're ready to save your changes. When the form is submitted, we are calling a handle submit function, which in turn uses the Inertia client to post to the user's endpoint with our form data. Now you can use form data as I have in this example, or you can just use a regular object that you might already have in state if you were using controlled inputs or controlled components. However, in a recent addition to the library, Inertia can now automatically detect if your visit includes things like files. And when you're working with files, you do have to work with form data like this. It's what is required to send multi-part form data requests, and that's what's needed via XHR if you want to upload files. So Inertia will automatically detect if there's any files, and it will convert to the form data object when it's needed to. Of course, you have all of your other HTTP methods available, like put, patch, delete, and so on. In another recent update to Inertia, they introduced a form helper. This is currently not available for React, but support is on its way. It's currently available for Vue, and it basically aims to abstract everything to do with a form away from being something that you have to configure and set up. Here's an example of what it does look like in Vue. So at the top there, we've obviously got our template, and down the bottom there, we've got what's actually going on inside of our Vue script. We can see that the form helper is providing us with bound or controlled inputs. It's handling submissions for us. It does the processing states while we're waiting for that request to be fulfilled. And it will handle all of the error handling and validation for us as well. So this helper looks to provide a number of useful utilities that I've often found myself implementing with or alongside Inertia. Now, it wouldn't be a cool SPA without some nice transitions or progress indicators when we move between our pages or when we submit a form. But in all seriousness, progress indicators help give feedback to our users that say the page isn't hung or isn't broken when you've performed an action. In Progress is a small library that provides the progress bar that runs along the top of your page during a request. Now they provide a plugin to make it quick and simple to get this set up running in your project. It's literally just an npm install, and then you run an init call there, and it's good to go. If we want to configure it a little bit more, then they do expose some arguments that you can pass down to control things like the delay, the color, whether or not they should include the default CSS, or In Progress does have an optional or an alternative layout where it uses a spinner rather than a progress bar running across the top. But if you want a little bit more control, or you want to implement your own custom indicator, then you can do so using request events. So during the Inertia request lifecycle, Inertia emits events when the request starts, when a progress event occurs, which is when you're uploading a file and we get a progress back from the server saying how much of that has been processed, or when the request has been finished. Now, what do we do when we have multiple components that need to share the same piece of data? Inertia Share is a way for us to provide common data to all of our pages. Take errors, for example. If your submission or your visit contains validation errors, then we'll want to display those to our users. Or flash data, giving the user some feedback about the action they've just taken. But there's no limitation to what you can share. A couple more use cases for this might be your feature flags, or library credentials where you don't want to hard code these into a component or chuck them on the window. Although you should be mindful that anything that you do decide to share will be loaded and passed in for every page that you visit. With our application no longer being server rendered with each page visit, what do we do if we deploy a new version of our application while someone is already browsing with our old bundle? Well, we use asset versioning. When we tell Inertia what version of our application we're using, it can detect when this changes. Now, the canonical example is to use something like a mix manifest, but you can return anything that you want. When Inertia detects that the version has changed, rather than hot swapping your components out, it will perform a hard visit to the next page, like a hard, it'll navigate to the new page and you'll get the loading symbol and everything will be downloaded again. And this gives you a natural way to refresh your bundle when it updates. This is jumpy. What should you do when you are making requests or visits to the same page and you only need to reload some of the data. This is often useful when you've got a filter or list on a page, but you also have other data that gets loaded in. When you update your filter, you want the list to update, but you don't need to go and reload all of the other data that is sitting on that page. Partial reloads are a way to only fetch a subset of the data that was initially loaded in. Partial reloads can be used with any inertia visit, an inertia reload, or when using an inertia link. In all three examples there, we are just asking inertia to reload the user's prop. But for partial reloads to be most effective, we need to be lazy loading our data. And we do this by wrapping all optional data inside of a closure. When inertia performs the visit, it'll determine which data is needed and only evaluate the closures for the data it needs. And this can significantly increase the performance of your pages where you have costly or, in some cases, optional data that you simply don't need to refresh every time. So what makes inertia so great? I don't believe that SPAs are actually hard or complex to build, although I've got no real experience building these commercially. However, if you've got existing applications that have routes, views, and some React or any front-end framework in them already, then leveraging inertia to transition to an SPA is incredibly simple. My team recently had a project where we were reskinning and revamping our entire supply portal. This was an application with about 20 different views, and all of these views had some different level of interactivity or discrete actions that needed to be performed. The application was all Bootstrap and jQuery, but using inertia, we could go and swap the pages out one by one, using them, rebuilding them with React and Tailwind. And that's one of the other benefits of inertia. If you ever need or want to break out of the SPA, you can. You just use a regular anchor link and you're back into a traditional Blade application. And the install is incredibly quick. It's 2 npm packages and a composer package. You also get a nice separation between your front end and your back end. The back end will handle all of your routing, your business logic, the persistence, data retrieval, and so on. And as a back-end developer, nothing has really changed for you. You are still working in the same framework, doing the same things you've always done. You just return it in a slightly different way. The front end then is purely about the aesthetic of your application and presenting this information to your users. We avoid the duplication of things like our routers and so on. You also don't have to build out as many AJAX endpoints. When we're returning an inertia component, we'll usually be passing in all the data that that component needs. It won't need to boot up and then go away and fetch more data from an API. With the use of partial reloads, we also have a way to refresh any specific bits of data once we've already loaded a page if we need to. By hot swapping components, we only have to boot React once. And additionally, sending the updated component and props as JSON significantly cuts down the amount of traffic we have to send over the wire when we're navigating to a new page, if we think in a more of a traditional Blade view sense. In production, with some of our simpler pages, it's not uncommon for us to see page load times in under the 250 millisecond mark. Having worked on large JavaScript projects before, bundle sizes can usually creep up quite quickly. Adding code splitting is literally a one-line change and a Babel package, but this only further aids in keeping the application snappy and quick to navigate. Now, this presentation wouldn't be complete without addressing some of our pain points. Hard visits aren't often something that you need to do. This is an SPA after all. But when you do need to perform one, there isn't an intuitive way to do this. You could use location.href or something similar, but we opted to utilize the same mechanisms that Inertia uses when it needs to perform hard visits for asset changes. And we've done that using a response macro. This returns a 409 response, and it uses a header that says what page we want to go to. And this is the same mechanism that Inertia uses when it's performing hard reloads or hard visits for asset changes. But that's it. We've not run into any other walls or pain points. We've built about 5 or 6 different production applications now. And these have been a combination of new builds or existing projects where we've gone back and we've ported them to use the Inertia library. However, if you do run into limitations, it's important to remember that at the end of the day, it's just JavaScript. There's nothing special about the Inertia library. If you need or you want to use Axios manually, there's nothing stopping you. Go for it. And at any time you need to, you can break out of Inertia. There's nothing jailing you in. That's it. Any questions? Go.
That was awesome, thank you.
Thanks.
I've used Livewire, and I was wondering if you've played with that and how you think it compares with Inertia. They both solve similar problems of making it so you don't need to have an API, but
I think they did. Well, I'm familiar
that.
with Livewire. I've really not used it other than watching a few Laracast videos or some stuff from Caleb about it. So I guess I don't have a lot to say about them. I think they are very similar. Obviously, Livewire is trying to get you away from JavaScript and back into managing them in your backend. But I suppose Inertia, and correct me if I'm wrong here, but I think Inertia is more trending towards the, if you're using React or any other front-end framework already, and you want to get that SPA feel where you kind of just slide through to the next page, if you will, I suppose Inertia allows you to do that, whereas Livewire, I suppose you're still performing hard visits to each new page. Maybe you have the benefit though that you don't have as large a JavaScript bundle, so it's still quick and snappy. But I guess, yeah, they're two different ways to solve a similar problem, I'd say.
Cool.
Yeah.
I was also curious why you chose React over Vue, given that Vue is kind of like the default option for the Laravel community.
That's a great question. I actually come from a Vue background. It wasn't until I started here that we stopped and had a conversation about whether we should be using React or Vue. I think Vue's great. I have nothing against Vue. But I think the job market for React is probably a little larger. At least from what I've seen in Brisbane, there are typically far more React jobs than there are Vue jobs, and I think that speaks to, at least from a hiring perspective, when you want talent and you want them to be able to come into the office every now and then, hiring locally, you kind of have to be at the mercy of whatever the most popular technology is, and for us that was React. That said, I think React and Vue actually share a lot of similarity. When you actually stop and look at the component lifecycle, they're all doing the same things. It's just a little syntactically different. I honestly don't think one is better than the other. It's just, yeah, from a purely hiring perspective, we found React was going to give us more options. So that's why.
Thank you.
Anything else?
At least if you say React, you don't have to clarify whether you mean Blade View or Vue.
Yeah. I was writing this out, and every time I was like, oh, I have to avoid putting Vue and Vue together, so yeah, cool.
We've got a question from the Plang Muppet. How does Inertia,
great name.
How does Inertia work in a high latency environment?
I suppose that's a good question. We don't really have that problem, so I can't speak to that. We use, one, we use Vapor. Two, our infrastructure is hosted inside Australia. Three, we're pretty fortunate in that we have a relatively okay internet speed. I mean, people will say what they will about NBN, but it's better than some of the speeds that you'll see in other countries for sure. So I mean, for us, it's not really a problem. All of our users have pretty high-speed internet connections, or if you're way out rural, then you're probably hopefully using something like mobile data, and it's a little bit quicker. But I think if you're using code splitting and you've booted the first page of your application, you've done most of the legwork at that point. You've downloaded most of your assets, and anytime you're navigating to a new page, you're only getting exactly what you need. The code splitting allows us to load only the components that we need at each time. So you're not downloading megabytes worth of JavaScript. If you've got a huge application, you're literally only downloading what you need. So whether or not it makes it any faster to get that data, I don't think is the case. However, you're being very efficient about what you are getting. You're only downloading what you need. Did you have a question before?
I was going to ask about accessibility issues, because spas are notoriously terrible for accessibility.
They are. Honestly, it's not something we've dived into fairly heavily. I think accessibility is important, but I think there's also a real cost to building highly accessible applications. For us, a lot of our users, because of the market that we're in, we tend to not have users that have disabilities. That's not an excuse to not be doing it, but we are a relatively small team, and we've been trying to move really quickly. At this point, we're trying to scale up really fast at the moment and get stuff to market a bit quicker. But I don't think there's anything about the Inertia library that stops you necessarily from building accessible things. If you're following best practices, if you're using your ARIA labels and you're building out your React components appropriately, I don't think that there is anything unique to Inertia that stops you from having an accessible spa. That said, I've not spent time
The only thing that
navigating.
really jumped out to me initially was the inertia link
Mhm.
component.
Mhm.
And you're not sure if that's a button or a link or...
Yeah, that said, we typically don't use, we aren't using the inertia link really for sending post requests. It's an option there, and I mention it purely because you can use it, and I can see some use cases where you might want to. And as far as the inertia library goes, or at least the inertia link goes, if you are sending a post request, then it is rendering it as a button. And then any extra props that you pass onto it that may not be like specific to the inertia link itself do get passed down into whatever element is rendered. So again, if you're providing some accessibility labels, then they will end up getting rendered onto that button that is there. Otherwise, at the end of the day, you can wrap that button if you want to in another component or another element, and you can provide those labels as unique too. Yeah? Anything else? Cool.
Cool. Thank you,
All right.
Jane.
Thank you, guys.